All right, welcome to the magical world of second-order ODEs. Those are equations that involve not only y prime, but also y double prime. For instance, we can consider the equation y double prime equals 2y prime plus ty squared. Now, the new feature here is that instead of having an initial position, like y of 0 equals 2, we now also have an initial velocity. Y prime of 0, for instance, equals 3. So this part is. Now, the good news is we still have an existence uniqueness theorem for second-order ODEs, sort of in the same spirit, which says the following. So existence uniqueness theorem. Uniqueness. Namely, consider the following ODE. So consider, as usual, y double prime is any function of y, its derivative, and t, with initial position y naught, why not, and initial velocity v naught, where again, those y naught and v naught are given. Then, similar to before, if f and its partial derivatives technically the derivative with respect to y and with respect to y prime are continuous, then there's a unique solution near 0. Then there is a unique solution. Y equals y of t for t near 0. Near 0, and once again, for instance, solutions cannot cross. So this is really the last time I'll talk about existence uniqueness here for second-order ODEs, but I do want to show you a really cool application of this, because a nice visualization of this is the game Angry Birds, where I want to show you a video of this. I know, it's so meta, YouTube within YouTube. But what is Angry Bird? Simply, it's a differential equations game where you determine an initial position, an initial angle, and you want to see whether the trajectory of the bird goes through a pig or not. So here you have the bird, like the solution to your differential equation, and the solution ideally goes through a pig. Now, this is really cool in terms of existence uniqueness, because non-existence would mean that suddenly the bird would blow up, whereas non-uniqueness would mean that the bird splits into two, sort of like having two trajectories. And last but not least, in terms of more serious applications, so we will use second-order ODEs to study harmonic oscillators in physics. And in fact, there'll be a whole lecture dedicated to them.